Hey guys, Chris from Green Bench Brewing Company here again. We're still on Module 4 of the Brew House. This specific slide is kettle design. So we're going to discuss the different types of designs that boil kettles will have. Let's get started here. All right. So the different types of systems that we're going to discuss today are as follows. We have direct fire heating systems, electric heating systems, steam jacketed heating systems, external heating systems, internal heating systems, then external heating systems. And the required reading for this one will be Chapter 11, Wort Boiling Systems, in the Brewer's Handbook, which should be a part of the curriculum. So take a look at that. There will be questions in the quiz regarding that specifically, a lot of things that are in there and in the slide. So, all right, let's hop into it. So direct fire heating systems. All right, so this is a very traditional way in which brew houses are made, in which kettles specifically are designed, namely because the technology, otherwise electric, steam jacketed, internal, external sort of heatings, weren't really invented yet. So when we were boiling anything ever, it was always with fire. So again, a traditional use of direct flame to heat wort. It is less efficient as far as the transfer of heat due to a localized bottom heating. So basically, a lot of the ways that these direct fire heating systems are designed these days is obviously you have the flame on the bottom, but they do allow for the flame to go up on the sides to try to increase the efficiency of sort of heat transfer around the side of the kettle. However, most of the heat is still going to be on the bottom. What happens because of this is oftentimes we'll have a scorching and or a caramelization, which is a common characteristic of a lot of direct fire brew houses, where you'll get a little more caramel characteristic, a little bit more sort of scorching of the sugars and the grains, because you have a localized sort of heat on the bottom. There is, however, a very lower upfront cost compared to steam systems, because in these systems you don't, for example, need a boiler room and a boiler itself and any sort of the piping that comes along with steam. So upfront cost, it is definitely less. All right, so then we also have an electric heating system. Electric heating systems are becoming more and more popular. So essentially the wort is heated via electric heating elements. So it is very efficient compared to direct fire systems, because you're just using heating elements that are inside of the kettle itself, and they're heating all the wort kind of equally. It's pretty equal throughout the wort as far as the transfer of heat. The efficiency, however, drastically decreased when you increase the system size. So the larger the volume that you're boiling, the less efficient electric heat systems can be. So low volume brewing, electric heat systems are fantastic. Not only do they have good heat transfer, there's no open flame, but they're just very, very efficient for low volume. So if you're anything upwards of, I'd say, 5-barrel brew house, that'd probably be as high as you'd want to go if you're doing electric. And I don't mean to say that that's the end-all be-all. Perhaps the technology will definitely change to the point where that'll be more efficient later on, as is now the common sort of brew houses that are on the market. You're usually going to see a 1-barrel or lower up towards about a 3-barrel brew house that's going to have an electric brew system. Otherwise, you probably won't see those. Similar overall cost as direct fire. Again, the heating, you have to pay for heating elements, you have control panel costs, all that kind of thing. There is, however, as the direct fire, it is lower upfront cost than, for example, a steam system. Also, it is oftentimes a lot easier on local permitting. So when you're trying to open the brewery and get the local permitting, there's no open flame. There's no boiler required, same as direct fire. There's no boiler required there. And there's also no heat source ventilation usually, because ventilation is usually required still for the kettle evaporate. You'll still need an air duct, a ventilation system from your kettle. But for example, on a direct fire system, you need 2 ventilation systems. You need one for your kettle, the steam that's coming off during the boil. You also need a ventilation for the flame itself. So you wouldn't need to do that if you go electric. There is also steam jacketed systems. So steam jacketed systems are very, very efficient because they give you a direct contact of heat to the wort in a very sort of there's a huge transfer because the surface area is large. So it's not just like a direct heating source. It's all over. It's surrounding usually the tank, and the bottom, so you have heat sort of coming everywhere. So it's very efficient heat transfer and extremely efficient energy usage once built. Using natural gas is very good on low energy costs for a boiler. So over time, steam jackets and having a boiler is very efficient when you're talking, monetarily. It doesn't cost a whole lot upfront. The upfront cost is higher, but over time, the maintenance is pretty low, and it's not over the top as far as cost. You do save on your energy. Jackets are usually arranged symmetrically, but are often asymmetric to encourage rigorous wort boil. So if you do have a kettle designed asymmetrically, your boil is going to kind of go all over the place and sort of bouncing off each other as sort of the mixture with where the heat's coming from. There is, like I mentioned, a higher upfront cost. You do have to pay for a boiler. You have to steam piping. You have to insulate your steam piping. All of that is fairly expensive upfront. Once you have it, again, energy cost isn't as bad. Here's an example of a steam boiler. This is actually mine. This is at Green Bench. So here on the left, we have our Ajax low pressure boiler. On the right, there's a condensate tank. So all of the steam will go in as steam. As it sort of slowly cools, it will turn into water. This is condensate. It'll turn into condensate. This is a vessel on the right, the little brown one, that will collect that water. It can then pump that water back into the boiler and reuse the condensate water to create steam again. So it says here, steam boiler and condensate tank installed at Green Bench Brewing Company. Now, again, higher upfront costs. Not only have to have the stuff, but you have to have it all piped. You have to have a plumber come do all that. We also built a room for it outside of our building. So building a boiler room is a fairly safe. That's where you usually want to put it, is outside somewhere in a room. Just in case there's problems, you don't really want anyone around it. So that can feed into the cost there. So this is insulated steam piping installed at my brewery at Green Bench. So this is a part of the cost. So all the white is all the insulated areas, and then the black parts that are kind of sticking out are like condensate traps and sort of release valves. So the steam comes in high and tight, kind of goes over, and then, as you can see here, is then installed at the back of my brew house. So this is the installed steam piping. So as on the last slide, you kind of saw it coming out of a wall, going up over, and it drops down and is inserted in each of the tanks. So the one on the right, closest to us on the picture, is our boil kettle. So it's got steam that goes into the sides. It's got one that goes in the side, one that goes in the side, and then one that returns. And then there's also a jacket that goes a little bit further, and it goes in the bottom. So the bottom's going to have an inlet and also a return. Same thing on the hot liquor tank, which is next to it, the far tank. So there's a side jacket and there's a bottom jacket, and obviously a supply and return for both of those. Okay, so internal heating systems. This is an extremely efficient way of boiling, designed to efficiently heat large volumes of wort. Often installed in the center of a kettle. It's called a calandria. It recirculates the wort from the bottom of a tube all the way up to the top. So it pulls the wort in the bottom and it shoots it all the way to the top and uses it as a cone there. So it hits the bottom of the cone and sprays back down. The beauty about these is that as they go through this cone, the cone is actually insulated and has jackets in it. So steam runs around the inside of the cone. So the wort that gets pulled to the tube is heated very quickly, and the beauty is that it's very low surface area. So only the liquid in that tube is getting like a huge amount of heat transfer. So similar to how we mentioned in the last slide, heat exchange technology, where you take you separate kind of a large amount of volume through these small plates, and there's enough that it exchanges heat very quickly and changes heat. Similar here with an external heating calandria, or an internal heating calandria rather, where the shell and tube will pull the liquid through, heat that little bit, shoot it back out on top. So it comes out instantly boiling. What comes out of the top is boiling. So it's this high contact surface area, and movement aids in the high efficient heat transfer. Steam jackets can still be installed in the kettle, so you can still have jackets around the outside, and usually they do. Usually they don't just have the internal calandria. They have the internal calandria, and they'll have jackets on the outside, jackets on the bottom, so you're still heating it the same way, but you're recirculating it. It is a high initial cost, and it is fairly high maintenance involved. It's very difficult to clean some of these, and oftentimes it takes manpower where you have to kind of hop in, have a device, take it apart, clean on the inside, because you have some scale buildup sometimes, depending on sort of the water profile and how much hops you use and all that. So sometimes the cleanup's difficult. With that said, it is extremely efficient for high volume brewing. So by the time you hit about 30 barrels, this is 20 to 30 barrels is when usually your engineer, the kettle designer is going to say, hey, listen, you might be interested in getting an internal calandria because you're not only will your boils happen faster, they'll also be a lot more efficient. This is a picture of an internal calandria. This is the internal calandria on the 30 Barrel Brew House at Cigar City Brewing over in Tampa. So as you can see, it's this big tube. They're actually laddering right now when I took this picture. So eventually when they cut it on, the wort will be sucked into the bottom of it and it'll shoot and hit that top plate, that sort of dome that's there. It'll shoot right up and it'll all spray back down and it'll just be immediately sort of boiling. All right, there are also external heating systems, which essentially are the same sort of technology as internal ones, but they're outside of the tank. So, highly efficient design that runs wort from the kettle through an externally installed calandria and back to the kettle. Also called a shell and tube, it is a design that allows for high surface area to heat wort that's passing through it. The kettle, like in the internal, can also still be jacketed with steam. External heating systems can be installed into existing steam kettles, which is kind of the beauty of external heating systems versus internal right now, is that you can build a brew house without an external heating system, and if you find you need one, you can attach an external heating system. It's a changing of the piping and installing of this, moving some steam to it, assuming that your boiler is big enough to operate that or to pump out that much steam for the kettle and for your external heating system. But that is always a nice thing about the external ones. You can kind of install it whenever. So it does, however, have a very high initial cost, and the installation is not cheap as well. So, but same kind of concept. You take the wort, you move it from your kettle, you run through an external heating device. It's a big tube, steam's all around it. The wort goes through it, comes out boiling, pump back to the boil kettle. Here's a picture of an external heating system. This is at Coppertail Brewing Company over in Tampa. So they have an external calandria on their system. So as you can see, there's a few, the big pumps, the blue ones there, are actually for steam. So steam goes in around the outside, wort goes into this tube, comes out the other end, and is pumped right back into the boil kettle. So yeah, that's it for this slide. And yeah, take a look at the reading and email me if you have any questions. Thank you.